Hi, 8th grade, it's me. Did you see me or did you just see my cute little grand dog here instead? This is Stella. Say hello to Stella. Say hello, Stella. She says hello. She's going to go now. Go. She's not going to go. She's just going to growl in my ear. It's fine. It's not a problem. We're going to review for science today. I can't quit laughing. You got to go away. We're going to review for science today because you have a quiz coming up this week. So say it with me. We've got to go through our types of bonds. We have covalent bonds, and we know, do the hands with me. Do the hands with me. Come on, pay attention. Do the hands with me. Covalent bonds share electrons. Ionic bonds give and take electrons, and metallic bonds pool electrons. So remember, in covalent bonds, there are two types of bonds. There's polar, yep, you got it. And what's the other one? Unpolar. Oh, I heard every one of you say it. That was fantastic. Polar and unpolar, non-polar. So polar is when they don't share evenly, like your friends that you had that didn't share their toys. Think of water molecules. They are a polar bond. They have a positive end and a negative end to the molecule, so they all stick together. If they didn't, the ocean would look like Dippin' Dots and the fish would be in trouble. Then you have non-polar covalent bonds. They're the ones that do share evenly, and that just makes for a much lovelier situation there. We also have double covalent bonds and triple covalent bonds. Double covalent bonds, remember, are when two pairs of electrons are shared. Triple covalent bonds is when three pairs of electrons are shared. So then in our ionic bonds, they happen between ions. That's how you get an ion. What keeps them together is they're taking or giving an electron. So the element then has a charge. It has either a positive charge or a negative charge, which makes them stick together. And then we have our metallic bonds, which happens as that pooling, which is why metals are so ductile and malleable, because they pool their electrons. So how can bonds happen? They can share, they can give or take, and they can pool. They can share, say it. They can share, they can give, they can take, they can pool. Say it again. They can share, they can give, they can take, they can pool. We have covalent bonds share, ionic bonds give and take, metallic bonds pool. Very good. So yesterday we started with our electron configuration drawings. Get out a piece of paper. You can push pause here for just a second. Get out a piece of paper. And we're going to do one. So we got to get to my whiteboard. My cameraman's going to move so we can get to my whiteboard. And we're going to see the whiteboard. My cameraman's going to move so we can see the whiteboard. And we're going to start with strontium. Strontium is SR. It is atomic number 38. It is period number 5, and it is group number 2. So if you remember yesterday, I told you that the best thing to do was to start just by numbering, and you know how many levels you're going to have by the period number. So we're just going to number 1, 2, 3, 4, 5. Level 1 is always going to be the same thing, unless it is what element? Say it. Yep, hydrogen. Good. So it's always going to be 1s2. And then the last one, the last level, you determine by your group number. That group number 2 tells us the number of valence electrons. So that's the number of electrons in the last level. So 5 is going to be 5s2. We had some magic numbers. The magic number is, say it, 8. Yep, great. 8 is the magic number. Why is it the magic number? Because 8 valence electrons makes an element stable. You had other numbers to remember. They were 2, 8, 18, 32. Do you remember them? 2, 8, 18, 32. And you had letters. They were S, P, D, F. Sir Paul defends France, S, P, D, F. So all of this has to add up to equal 38, which is our number of protons, but it is also in a neutral element our number of electrons. So let's see if we can start filling this in. It's going to be 2s2, and then we remember we always have to go back and put the level number again. So we're in level 2, sublevel P, and it's 2, 6. Okay, so let's get our count going over here. We have a 2, 2 plus 6 is 8, and down here we have a 2. And remember, this has to add up to get 38 in the end. So we're going to have 3s2, 3p6, 3d10. Okay, so that gives us a grand total here of 18. You need to stop right now and add this together. You're 8 short, right? So this level needs to look just like this level with 8. So you're going to have 4s2, 4p6. That gives us an 8 over here. If you add all of that up, that gives you 38, which gets you your atomic number. So you are correct. So we're going to do another one, and I'm going to give you a challenge one because I think you're ready. We're going to do oganesson. Oganesson is atomic number 118. So this is as big as it will ever get. Symbol OG, atomic number 118, period number 7, group number 18. So oganesson, wow, that's going to be a big one. How many levels are we going to have to put? 7? Right. How do we know that? Because that's the period number. Good. Group level 1 is going to have 1s2. How do we know that? Oh, because they all have 1s2, unless it's hydrogen, which has 1s1. Wonderful. Level 7 is going to have how many electrons in it? Yep, 8. Why? Because it's in group number 18. So it's going to be 7s2, sorry, 7p6. 2 plus 6 is 8. So I've got my 8. I've got my 2. Now, I want you to pause this for just a second. This is your challenge. And I want you to see if you can fill in the rest of the blanks. Don't cheat. I'm going to go ahead and fill it in, but you're going to see if you can do it on your own. Okay, are you back? Oh, you're back. Hey, oh, here we are. How are you doing? Okay, so let's see how you did. You have, instead of that triangle shape, you're going to have more of a flattened, but it still gives you the wedge. So there's one of your first clues to look at and see if you got the right shape. Then we add it up. So up here I have 2 plus 6, there's my 8. I have 2 plus 6 plus 10, there's my 18. 2 plus 6 plus 14, there's my 32. 2 plus 6 plus 14, there's my 32. Now, when you were doing it, when you got here, you should have stopped, because you needed to know what this last level here was going to look like. Well, you're 18 short. If you add all of that up, you're at 100. You need 18 more. So this one had to be 18. 2 plus 6 plus 10 is 18. You add all of that up, you get 118. Remember, mathematically, there's lots of ways you could come to this. There's only one right way to come to this. So what if I asked you to do the electron dot diagram for oganesson? So I'm just going to write the symbol right here, oganesson. The dot diagram, does it show, do I have to put 118 electrons around that? I certainly hope not, because we would be here for a very long time if I had to do that. No, I do not. All I have to do is show the valence electrons. How many valence electrons are in organosine? 8. Wonderful. So it's just 1, 2, 3, 4, 5. Watch, it goes under it. 6, 7, 8. Do not put that dot out here. That's the incorrect way to write it. It goes like that. So make sure that you're doing those dot diagrams correctly. All right, I'll see you later in our Google Classroom. Have a great day. Bye.